All right, so this is the third video, the final video. I know there's three in these. It's quite a lot on polygons. And particularly the first two were on quadrilateral shapes with four sides. But this one is on triangles, on a specific triangle theorem. It's known as the triangle inequality theorem. And I can tell you what it is, but I'm going to show you first, and then and hopefully make a little bit more sense. So what I got here are three sides, and they're going to be sides of the triangle in a second, but right now they're just laying right next to each other, so I can show you something. And so what I want you to recognize is you got three sides, and the red one's obviously the longest one, and then the black and the blue one are the shorter ones. And if we line these up next to each other, and so they're about right there, what you're going to notice is the two smaller sides are not as long as the longest side. Um, and so what that tells me, I guess that doesn't tell me anything yet because I don't know what the theorem is. What I'm going to try to do is make a triangle with these three sides. And again, the two smaller sides are, are shorter if you put them together or if you add them together, the longest side. And so what I'm going to try and do, it's kind of hard to do this, but I'm trying to make a triangle here without changing the sides of the blue or the black one. And so I'm move this down here and move this black one down here. And you probably can see already that is not possible, right? So one thing the triangle inequality theorem says is if you have two sides that are smaller, um, then the two smaller sides are when you add them together are smaller than the longest side. You can't create a triangle. Okay. So let's look at the case when they're not smaller or not larger, but when they're actually the same size. So let's say let's put these back to be parallel to each other. And let's make them so the two smaller sides, the black and the blue side, are the same length. They don't have to be the exact same length, but the same length if you add them together as the red one. So like right now, if you see here, the black and the blue, if we add them together, they are the same length as the red one. So they're not smaller, but they're not larger. They're equal. So we want to see here. Can we create a triangle now? And so again, I'm not going to change the size of the black and the blue. When we add them together, they're the same size as the red. So here we go. I'm trying to bring this down here. I made it a little bit longer, so make it a little bit shorter. And then the blue one here, bring it down. It's kind of hard. But what you can see here is they still are not forming a triangle. And if I bring these down, they're never going to touch until they're parallel to the side, and that doesn't form a triangle. So the theorem, or what the triangle inequality theorem says is, if you look at the two smaller sides of a triangle, and it doesn't matter if it's a right triangle or whatever, any triangle, if the two smaller sides added together are smaller, okay, or equal to, so they can't be equal to either, then it does not form a triangle, okay. For it to form a triangle, the two smaller sides, so the black and the blue, have to be longer. So let's make this blue one a little bit longer and the black one longer. So now you see, if I add these together, they are longer than the red one. And so now, by the triangle inequality theorem, this should form a triangle. So let's try it here. So kind of move this so I don't change the size. Okay, maybe I need to move it up a little bit more. And I think you can see, but I'll make it anyway, is that this will form a triangle eventually. You know, I'm changing the side a little bit, but it doesn't really matter in this case because the two smaller sides are longer than the red side if we add them together. And you can see there we formed a triangle. And so again, the triangle inequality theorem says that if you take the two smaller sides of the triangle and you add them together, and they are longer than the longest side, it's kind of a long theorem, then it does form a triangle. So one more time, the two smaller sides for it to be a triangle of the triangle have to be longer when you add them together than the longest side. Okay, so let's look at some Ames questions and see how they ask them, because they ask them in a couple different ways, and we'll look at a couple different problems. So here we go. Here's the first one. I'll make this lower so this doesn't get in the way up here. It says a triangle has two sides of length 12 and 8. Okay, it says the length of the third side of the triangle could be all of the following except which length. So here we got to look at all 4 choices and see which one is right. So what I'm going to do here is I'm going to get a triangle. Let's see here. Just a second. Sorry that my pen went out. I think I got it fixed. So yeah. So what I'm going to do is draw a triangle here. And I'm going to draw not a right triangle or anything. This is just a regular triangle here. So let's see if I can get it down here. And then we're going to kind of apply that. So I'm going to make one side obviously longer than the others, and then the other two. And so there's my triangle, and it's not going to be drawn to scale, but it'll work for me. So it says two of the sides are 12 and 8. And so if we got to see the length of the third side of the triangle could be all the following things. So we're going to start with 6 and 6. So it says 6 is, that's my smallest side, right? If I have 6, 8, and 12, so I'm going to put 6 here. My next biggest side is 8, and this is 12. And so what we want to think about is, does that work? And so again, the triangle inequality says that if we take the two smaller sides, so 6 and 8, when we add them together, so 6 plus 8 is 14, they should be larger than the longest side, 12. So 6 plus 8 is 14. 14 is bigger than 12, so that works. So 6 does work as a triangle, a side of the triangle. However, we're looking for which one doesn't work. So A does work, so that's not the right answer. So we're going to cross that out. Okay. The next one is 8, and what we have here is that's the next side, and so I'm going to erase that, big eraser. And so my two small sides are going to be 8 and 8, so they're the same. So my longest side is still 12. So here we go with 8. So again, the two smaller sides added together should be bigger than the longest side. So 8 plus 8 is 16. 16 is bigger than 12. So that works as a triangle. So again, that is not my answer. So I'm looking for the one that doesn't work. So that's not my answer. So now it says 17. Let's use a little bit smaller right here. So 17 is bigger than 12. So 17 is going to be my biggest side. So I'm going to erase that, and I'm going to put 12 down here because now 8 and 12 are my smallest sides, and 17 is my longest side. Okay. And again, we should add these together and see if they are longer than the longest side, or bigger than the longest side. Let's say it like that. So 12 plus 8 is 20. Is 20 bigger than 17? Yes. So 17 works. So hopefully it's B, and we'll get it. So now it says 21. So 21 is now the biggest side. So let's put 21 here. And 8 plus 12 is 20. Is 20 bigger than 21? No. So that does not form a triangle. And so D is the one that doesn't work. And so D would be our right answer. Okay. Hopefully this is making a little bit more sense as we do more examples. So let's look at another type of AIM problem. And this is the one that is on, or is like the one that's on the practice aims. So this is probably a good one to try here. And so let's see what it says. It says given x is a whole number. So a whole number, if you remember, that is 0, 1, 2, 3, 4. So the positive integers. What is the smallest possible value of x? And so what we're going to do is we're going to plug in these values for x here, and then see if it forms a triangle, and then we're going to pick the smallest one. So we'll just start with the smallest one, so if it works, then we know that's the answer. We're going to start with 1 and work our way down. So here we go. We're going to plug in 1 for x. So here we're going to plug in 1. That's a 1 there. So 3 times 1 is 1, or 3 times 1 is 3, sorry. Plus 1 is 4. So this side is 4. I plug in 1 here. 1 plus 9 is 10. So that side is 10. Plug in a 1 here. 1 times 10 is 10. Minus 2 is 8. So my two smaller sides are 8 and 4. Is 8 plus 4 is 12. 12 is bigger than the biggest side, or bigger than the longest side. So that forms a triangle. And so that's my correct answer. Now, some of these others might work, but again, it says the smallest possible value. And since 1 is the smallest value here, that has to be the smallest one of all of them. And so A is going to be my answer. Okay? And if that one didn't work, then I would just go down and I would plug in 2 for x and do the same thing. Okay, so let's look at another example here. Last one. This is a word problem, so don't stress out about these. Just read and let's write down the information that they give us. It says Bill wants to fence off an area in his yard just for dogs. In order to maximize this, the area will have to be triangular shaped. So what that tells me right off the bat is that I should probably draw a triangle. Okay, and so here we go. I'm just going to draw a triangle. I don't know what his yard looks like, but it's a triangle shape, and that's all it says. That's all I care about. It says two sides of the dog's yard will be 10 feet and 15 feet. And it says, what is the maximum length of the third side can have from the choices given? So it wants the maximum. So before it asks for the smallest, then we start with the smallest number. So here, if it wants the maximum, I'm going to start with the biggest number and then work my way down. So I'm going to start with 25. And so 25, my sides are going to be 25, 15, and 10. So 25 is my biggest side, so I'm going to put it right here. And I got 10, and I got 15. And so if we do our math here, we should add these together, and the two smaller sides, and if they are bigger than the longest side, then it'll work for a triangle. So 10 plus 15 is 25. Is 25 bigger than 25? And the answer is no. It's equal to, but it's not bigger. So that cannot form a triangle. It's got to be bigger. It can't be equal to or smaller than. So that is not my triangle. So let's get rid of 25. That's not the answer. Okay. And so let's try the next biggest number, and that's 24. Put 24 here. Okay. 10 plus 15 is 25. Is 25 bigger than 24? And obviously it is. So that's going to form a triangle. And so my answer here is going to be C. And 16 might work, and 5 might work, but again, it's asking for the maximum. So you gotta make sure you read the question so you don't pick the wrong answer. Okay, so that's the final video for polygons. You should try the practice and then attempt the assessment. All right.